Everybody, I hope you had a good chapel, and for those that are just starting your morning, if you can't watch this whole thing, please make sure that you go on to dowdylca.tk. Dowdy, as you know, dowdylca.tk, and watch the rest of this, because tomorrow's lesson is going to jump right off of this one. So dowdylca.tk, you're looking for the geometry tab. Okay, and we are ready to start. Backtracking just a little bit to what we did yesterday, finding the geometric mean of 2 and 10. If you recall, that's different than just finding an average. It's finding the geometric mean, and the geometric mean is the parts of the proportion that are equal. X and X, those are geometric means, and the other two numbers go in the other places. Recall that you cross multiplied to solve that, and then you needed to factor the 20 so that you could find the root. I know that we went over this more carefully yesterday, and this is just a quick reminding. So the geometric mean of 2 and 10 is actually 2 times the square root of 5. Sometimes we were given that you're supposed to find the geometric mean of some numbers, and when you go through the process, the geometric mean is the variable, you find out that it comes out even. If it comes out even, just leave the number alone, and you don't have to go through that process of breaking it down by factoring. Okay, just a reminder. If you're actually given the geometric mean and you need to find one of the missing numbers, recall that yesterday I pointed out that you needed to put the geometric mean in these two spots, the mean of the proportion, and then you needed to cross multiply in order to solve and to get your answer. Alright, so this is our jumping off point for today. We have quite a bit of material to cover. Now I am going to take the time to stop and write the notes down myself. I'm trying to record this in real time so that you should have enough time to write down. Please don't pause this video to catch up. If you do need to go back, if there's a little time at the end of the class, you can ask the teacher to go back in the video. However, if you find yourself behind, make sure that you go online and watch the lesson. Okay, so moving right along, we have a new theorem to talk about. It says, in a right triangle, the length of the altitude from the right angle to the hypotenuse is the geometric mean of the lengths of the two segments of the hypotenuse. So what I'm going to do right now is I'm actually going to take a minute and write that down so that I don't get too far ahead of you. So I'll be writing as you write. Theorem 9.2. In a right triangle, the length of the altitude from the right angle to the hypotenuse is the geometric mean of the lengths of the two segments of the hypotenuse. Okay, then make sure that you draw that picture. Alrighty, as you draw the picture, please make sure that this is a right angle and this is a right angle. Now we need to talk about what this actually means. Okay, the altitude from the right angle, that's this segment right here. That's the altitude that comes from the right angle. Okay, and an altitude comes from a corner, goes to the opposite side, and actually forms another right angle. This is the geometric mean of the lengths of the two segments of the hypotenuse. Well, what are the two segments of the hypotenuse? B and C. So B and C are the two segments of the hypotenuse. So if the altitude is the geometric mean, that goes in those two matching spots. And I do see a little error here. This should be B and C. A and A are the geometric mean, that's the altitude, and B and C are the two segments of the hypotenuse. So you break this down, make sure that you write this in. Okay. A is the geometric mean, so it belongs in the matching spots, and B and C are the two segments that were made on the hypotenuse. Alright, let's look at a problem. Alright, so we have this figure and it's drawn just like that. We have a right angle, we have a right angle, and so we have a big right triangle. We have an altitude that comes from it, and we're going to be asked to find GM if we're given BG and GA. So let's get this problem written down. Find GM, you're going to draw a nice big right triangle with an altitude, B, G, A, M, and we are given that BG equals 9 and GA equals 12. Now, just like in any problem, you're usually supposed to write the numbers onto your picture first, so we want to go ahead and do that. I do need to do a reveal screen. There we go. Alright. So let's just take a look here. Okay, so first thing we do is we put the numbers and the variable right onto the picture so that you can begin to evaluate. Notice the geometric mean. This one is the geometric mean of these two. So when we set up the problem, you put an X in those geometric mean spots, and a 9 and a 12 in the other two places. These are the two pieces of the segment, the two pieces of this hypotenuse that were created when you drop down the altitude. So then you cross multiply. You get x squared equals 108. And then we need to square root both sides to solve. If you recall, though, we have something to do with that square root. You could put it right in your calculator, and when you put it right in your calculator, you'll get a decimal. But I also want to remind you of how to do this in radical form. So I'm going to take a second here to get caught up with my writing. as you do. So 9 goes with x, like x goes with 12. So x squared equals 108, and x equals the square root of 108. Now I hope that a whole bunch of you have remembered that you need to do a factor tree in order to solve this. I'm going to put this up so I can not reveal everything. Do a factor tree. Find out the factors of 108. So we have a 2 and a 2 and 3 3's. So when we write it like this, remember you're looking for pairs, because the square root is really what number times itself gives you the answer. So you have a 2 times itself, so that means that 2 is part of your answer. You have a 3 times itself, so 3 is part of the answer. But this 3 does not have something to go with it. So the 2 comes out, the 3 comes out, and you're left with the square root of 3 underneath. And you actually do need to clean it up a little bit and simplify in order to get that final answer down. So once again, you factor the 108. 54, 2. 54 is 2 times 27, 3 and 9, and 3 and 3. If your tree looks a little different, that's okay. You're still going to get all the same exact numbers, because that's how prime factoring works. So you have the 2 2's and the 3 3's. Sorry about that. I don't know what my computer was trying to get me to do. We bring out a 2, we bring out a 3, and we end with 6 times the square root of 3. Okay. Hopefully that is done and in your notes. We're going to look at another example. So you're going to draw the same basic picture. The same exact picture, actually. We do have a right angle and a right angle here. It only works if there's actually right angles there. And we have a brand new thing we're asked to find. This time we're asked to find AG when we're given GM and BG. So let's get that problem sketched into your notes. Okay, we have triangle BGAM. Find AG given GM equals 8 and BG equals 6. All right. Now, first step of the first step of the problem is always going to be to write in your numbers and your variable. Okay, so GM is 8, BG is 6, and we're going to be trying to find X. Okay, now in this case, our geometric mean is this one right here. It's the 8. So because this is the geometric mean, okay, that one is the geometric mean. It goes right there. Then that means that the 6 and the X go in the other two places. Okay. Once again, the 8's the geometric mean, and the 6 and the X go in the other places. Notice in the other slide I wrote the 6 here and the X here. Doesn't really matter, because you're going to cross multiply those two anyway. Okay, so the 8's have to go in the geometric mean spot, and the X and the 6 go in this one and this one, in whichever order you would like to put them in. Okay, after that, cross multiply, Notice this is not a square here, so we are not square rooting this one. You're just dividing by 6. Reduce your fraction. We get our answer in this case being 10 2/3. I'll give you a second to get caught up on your writing. Okay. X goes with 8, like 8 goes with 6. 6x equals 64. X equals 64/6, which reduces and gives you 10 2/3. Alright, so that's our first theorem. Alright, the one down the middle is a geometric mean. You need to keep that in mind. We're going to take a look at a couple of other geometric means. Alright, I want to not have that come up anymore. Okay, let's take a look at the next theorem. In a right triangle, the altitude from the right angle to the hypotenuse, it's the same basic beginning, divides the hypotenuse into 2 segments, which we already know. Now we're talking about each leg of the right triangle being a geometric mean. And it's a geometric mean of the hypotenuse and the segment of the hypotenuse that's adjacent to the leg. Okay, so let's take a little minute and write that down, and then we'll talk about what it means. Theorem 9.3. In a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into 2 segments, and each leg of the right triangle is the geometric mean of the hypotenuse. And segment of the hypotenuse that is adjacent to the leg. Okay, make sure you get this picture drawn in. That's a D down there. A, B, C, and D. Alright, that should be enough time for you to write those things down. We're just going to add a little bit to your markings here. In order to explain it a little bit better, I just put these lowercase letters in to refer to the lengths of the different sides. A, B, C, just like we did on the last one. Then I put in a D, E, and F so that you can refer to them a little bit easier, and in your notes you'll be able to do some shortcuts. So let's put in those markings to represent the side lengths. Okay. Alright, let's dissect this a little bit. Alright, so each leg of the right triangle is a geometric mean. So here D is a leg of this big right triangle. it's a geometric mean. So that means that D and D go in the spots of this proportion that are the geometric mean places. It is the geometric mean of the hypotenuse. The hypotenuse is the whole length, and the segment adjacent to that leg. So B right here comes right up against D. So that's how we choose F and B. So the leg is the geometric mean of F and B. Now you're probably saying, wait, there's another leg, and there is. That's why I have a second proportion set up here. E is also a leg, so it is also a geometric mean. So you're going to put E here and here. And the hypotenuse is F, so that will still go up here. But the side adjacent is C. So that will be the other equation that you get out of this particular theorem. So here we have F over D equals D over B, and F over E equals E over C. Alright, so we're going to use these proportions. Now these are very important. You need to make sure that these go into your notes. You need to make sure that you study them. You will probably, a little later on, I have a summary for you. You will probably put that summary on your notes sheet when you take your test. So that when you have a picture like this, even if it's turned all around, you will be able to figure out what goes in these proportions and which are the geometric means. So let's get an example problem. Let's do a reveal screen. Okay, here's our example problem. We're given that QR is what we're supposed to find. RS is 5. And RT is 12. So let's get that problem written down. Example. Find QR if RS equals 5 and RT equals 12. I'm going to draw the picture in. Okay, you should always draw the picture in. We have an altitude, R, S, T, and Q are our points. 5 is RS, 12 is RT, and X is the other one. Okay, so we need to set up a proportion for that. Remember that the leg is the geometric mean of the hypotenuse, and the piece of the hypotenuse that is closest to the other leg. So here's our proportion. Okay, 5 goes with X like X goes with 12. This one's the geometric mean. 5, the close one, 12, the whole hypotenuse. You need to cross multiply. And I do apologize that the answer is actually over here, but cross multiply. 5 times 12 is 60. X times X is X squared. And you know that then you need to take a square root. Square root of 60. If you break down 60, you get 2 times 2 times 3 times 5. You can make sure that you take your time to do that. If you're not seeing it right off the bat, there's a pair of 2's, so a 2 comes out, and you're left with 3 times 5, which is 15. Okay. Alright, let me make sure everybody had a chance to get caught up with that. And let me get my phone. Okay, so we're getting time to get caught up on the writing just in case anybody had gotten a little bit behind there. Okay, so 60 is x squared. We're taking the square root of 60 is x. So x is the square root of 2 2's and a 3 and a 5. So you have a 2 that comes out. 2 times the square root of 15. Alright, so that's that one. We need to continue on, and we find, here's an example. So we're supposed to find AD if AB is 9 and BC is 3. Now notice that the picture got turned around. I want you to be able to do these problems regardless of how the picture is turned. So here AD and DC are the legs, so we need to keep that in mind. We need to also keep in mind that when we plug in our numbers, 9 and 3, this is our geometric mean, x and x. 9 is the segment that is closest. I have a little question mark here. 3 isn't the part that goes here. You got to think it through. In the big triangle, the hypotenuse is actually this whole distance. So since the hypotenuse is the whole distance, you have to add the 9 plus the 3 to be able to fill in this blank. Okay, so I'm just going to fill in your blank. It's a 12. So now we need to cross multiply. When we do 9 times 12, that gives you 108. We figured out 108 today already, and that came out to be the 6 times the square root of 3. So it still is 6 times the square root of 3. Let's make sure everybody had a chance to write all that down. Example, find AD if AB is 9 and BC is 3. We have a beautiful picture here. Okay, we have our right angles, 3 and a 9, x, A, B, C, D. 9 goes with x like x goes with 12. X squared equals 108, so x equals 6 times the square root of 3. Alright, so that's that. Alright, I want to give this as a summary. Okay, let's summarize. Okay, if an altitude comes from the right angle, it creates 3 geometric means. C is 1, D is 1, and E is 1. So we want to write this down. This is the little picture that I really believe should go on your notes sheet. It just summarizes everything we just did, and in the next slide we will fill in those missing pieces. So let's get this down. You don't have to write, yeah, I guess you do need to write everything. So summary, if an altitude comes from the right angle, of a right triangle, it creates 3 geometric means. So these proportions are true. And we've got your picture. And we have all of your labels. Don't miss any of them. We got A, B, C, D, E, F. And F is that hypotenuse. So what we have here is C is a geometric mean and belongs in the geometric mean spots. E is a geometric mean, and so is D. Alright, so if C is the geometric mean, then hopefully many of you see that A and B are the ones that go here and here. If we're talking about E as a geometric mean, F and B go here. D as a geometric mean gives you F and A. Okay. A and B go with C. F and B go with E. And F and A go with D. So let's make sure everybody has got that. And that will be a really good little tool for you to have in your notes to be able to solve any problem. Okay, so all I have left is really one example, even though it looks like 4 slides. One example just so that you can see you're responsible for being able to do any problem relating to finding any one of these parts. So let's just get one more going, and then when you do your homework, you'll be able to see if you really have it. And make sure that on Monday, if there's anything that's confusing to you, please, please, please make sure you ask the questions. Okay, here's an example. We have a nice little figure here, some givens, and you are to find AC. So let's get this last example into your notes for the day. They are right angles. These problems do not work if we don't have right angles, so I have to make sure that I give you that these are right angles. That is important. So you're getting this all written down into your notes. Don't miss anything. A, B, C, D. We are given that BC is 3, and you should begin to actually plug those in. If you get ahead of us, that's not such a bad thing. It just means that you have figured it out. Alright, so we plug in your numbers. When you plug in the numbers, you begin to see, hopefully, what pattern it is that you're going to use to be able to solve. X is AC. We have 3, and we have 6. AC is the hypotenuse. Think it through. Hopefully you're figuring out which one is the geometric mean. Remember, we have 3 choices. Okay, and it's not this one, it's not this one, but we have something going on here. So 6 is going to be our geometric mean, and 3 and X are going to go in the other 2 spots. 6 is the geometric mean, 3 and X go here. You can cross multiply then, and once you do that, it comes down to a fairly simple solution that X is 12. So since X is 12, AC equals 12. Alright, it is your job now to study and make sure you understand all this. Assignment 50 is due Friday, so please make sure that you complete that and put that into the homework tray.